Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if kids learn numbers differently when they're playing on a tablet versus with real toys? Well, this new study dives right into that question. Today we're exploring how kids learn about numbers and what happens when we move a classic childhood number game from the physical world to the digital one. For over 50 years, researchers have used a game called the Give a Number task to understand how young children grasp the meaning of number words like 1 or 3. Think about it. You have a bunch of little toys, say plastic apples, and the researcher asks you to give me 3 apples. Based on how many you can get right, they figure out what numbers you truly understand. If you can only give 1 apple correctly, you are called a 1-knower. Get 3 right consistently, you are a 3-knower. This task has been super important, replicated across many countries and languages, and it even helps predict how well kids will do in math later on. But here is the catch. For decades, every researcher has done this game slightly differently. Some use different toys, different ways of asking, different scoring. This makes it really hard to compare results from one study to another. It is like trying to compare apples and oranges, but in science. So, to fix this, scientists are looking at using digital versions. Imagine playing this game on a tablet or computer. The idea is that making it digital could make it much more consistent. You can standardize the look of the objects, how they appear, how the game works, and even do it online, which could involve kids from all sorts of backgrounds. Plus, it might reduce issues with kids trying to physically arrange objects while counting. That is exactly what the researchers in this study wanted to find out. They asked, can a digital give a number game be a good replacement for the old physical version? To test this, they had kids play both the traditional physical game and a new digital version. They wanted to see how similar the results were and if the kids got different knower levels from each. They tested 169 young children around 3.5 years old from preschools in the US and Canada. What is cool is that they also played with how the given items were organized, either in a messy cluster or in neat rows, to see if that made a difference. So here's how they did it. For the physical version, kids were given a box of plastic fruits. An experimenter would ask them to give a certain number, like, can you give me n lemons? And the child would pick them up and put them on a plate or a tray. In one group, the child could just put the fruits anywhere on a flat plate. In another group, they had to place the fruits onto a special tray with little squares, sort of like a grid. If a child messed up, like putting too many fruits somewhere or not enough, the experimenter would ask them to count and fix it. Then came the digital version. Kids played on a laptop. They'd see 15 fruits on the screen. When the experimenter asked for, say, 3 lemons, the child would press the spacebar. Each press would move another fruit down to a collection area at the bottom. Just like the physical task, in the unordered digital version, the fruits would appear in a random cluster at the bottom. In the ordered digital version, they'd line up neatly in rows, mirroring the physical tray. If they made a mistake, the experimenter could reset the game for them to try again. The way they scored the kids was standard, to be an n-knower. They had to get the correct number of items at least 2 out of 3 times for requests of n. They also couldn't just give n items for requests of other numbers. Basically, they had to consistently give the right number for a specific amount and not for others. So, what did they find? This is where it gets interesting. When they looked at the knower levels overall, there was pretty good agreement between the physical and digital tasks. Think of it like this. If a child was a 3-knower in the physical game, they were likely to be a 2-knower or 3-knower in the digital game. They used fancy statistical terms like kappa to measure this, and generally the agreement was considered moderate to substantial. This suggests that the digital version is giving a similar picture of a child's number knowledge as the physical version. But, and this is a big but, this agreement wasn't perfect for every number. They found that for higher knower levels, like 3-knowers, 4-knowers, and especially 5-knowers, the agreement between the two versions dropped a lot. Some kids who were, let's say, 4-knowers in the physical game were much lower in the digital game. This means that for some kids, the precise number level they achieve might shift depending on whether they're using toys or a screen. Interestingly, when they grouped the kids into broader categories like non-knowers, those who struggled with even small numbers, subset knowers, those who knew some numbers but not high ones, and CP knowers, those who understood numbers up to 5 or 6, the agreement was much higher. Now, you might think maybe one version is just easier, right? Well, they investigated that. They looked to see if children consistently got higher knower levels in the physical task or the digital task. And interestingly, they didn't find a systematic difference. Some kids did better on physical, some on digital, but overall, there wasn't a consistent bias favoring one over the other in terms of the level of number knowledge reported. But there was a difference in overall accuracy. When they looked at how many trials a child got right across the board, kids tended to be slightly more accurate in the physical version than in the digital version. Even though the lower level classifications were generally similar, the children were just a bit more successful at giving the correct amounts when using physical objects. The arrangement of the objects, whether messy or neat, didn't really change this accuracy difference between the physical and digital tasks. So it seems like the physical interaction itself might give kids a little edge in accuracy, even if it doesn't drastically change their overall lower level classification. So what is the big takeaway? The researchers conclude that the digital version of the give a number task is pretty good. It gives classifications that are comparable to the traditional physical version. This means that for many research purposes, using a digital version is a really viable option. Think about it, the digital version is easier to standardize. You can administer it remotely, and it reduces all sorts of variability that comes with physical materials and different experimenters. This is huge for making research more efficient and inclusive. But we have to keep in mind that kids were a little more accurate with the physical objects. So, if you are looking at very fine-grained details of accuracy or comparing your results directly to older studies that only use the physical task, you might need to be a little cautious. The researchers also point out some limitations. They mentioned that for some of the higher lower levels, they didn't have a huge number of kids, which can make those specific findings a bit less certain. They also suggest that if you use this digital task in communities where kids aren't as familiar with computers, the results might be different than in populations already comfortable with screens. They also tested a specific version of the game where kids were prompted to give specific numbers every time. They wonder if a titrated version, where the difficulty adjusts based on the child's performance, might yield different results, though they suspect it would be similar. So, to sum up, this study provides strong evidence that digital give a number tasks are a solid tool for measuring number knowledge in young children. They're reliable and give results that line up well with the traditional physical method, offering exciting possibilities for more standardized and accessible research. While kids might be slightly more accurate with physical objects, the digital version seems to capture the essential understanding of number words effectively. What I find really compelling about this research is how it bridges the gap between traditional methods and modern technology. It validates the digital approach while also highlighting the subtle differences and where we still need to be mindful. For educators and parents, it suggests that digital learning tools can be effective in building number sense. But we should also remember the value of hands-on, tangible experiences. Future research could explore how different types of digital interfaces children interact with, like touch screens versus mouse clicks, might influence performance, or how cultural differences in technology familiarity play out. I think this is just the beginning of understanding how technology can reshape how we study and teach early mathematical concepts. What do you think about using digital games to test kids' knowledge? Let me know in the comments below, and if you found this breakdown helpful, please give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more science insights, and hit that notification bell so you don't miss our next exploration. Thanks for watching, and I'll see you in the next video.